Hey guys, welcome to my Unit 8 Conics summary video. One second, let me focus that for you. There we go. Okay, so I've already written the formulas and I'm going to kind of go through them. So I'll give you a second if you want to get this one written down. This is the equation of a circle. And one thing I'm just going to start off with so that we don't have to write this four different times is come down here to the bottom. All conics have a center of HK. I could technically write this in every single notes section for every single shape. Instead, I'm just writing this here at the bottom. If you want to make a note on the top or the bottom yourself, that is an excellent idea. And I do it in all caps because it is that important. So, moving back to the circles. The center is going to be these two, and all points on a circle are the same distance away from the center, so your radius equals r. And that's pretty much all you need to know about the equation of a circle. I am going to add a note that this is basically the Pythagorean theorem. So if you already knew the Pythagorean theorem, a squared plus b squared equals c squared. A squared is just x minus h, or a is just x minus h, b is y minus k. Again, h and k are the center of that circle. And that's pretty much it for a circle. They just have a center and a radius, and that's it. For an ellipse, you will notice, sorry, I forgot one part of this. There we go. That instead of r squared, we have 1. That's because each variable, x and y, they sort of get their own radius. So the radius for the x part is underneath the x value, and the radius for the y part is underneath here. So these are sort of like the mini radii. A and B can switch spots. So A is just always the bigger one. So if x is first, that's going to be an ellipse like this, where it's longer in the x direction side to side. If we switched it and a squared moved over here underneath y, that would be more like this. Okay, on a circle, the reason why it doesn't matter and why they don't have it is because it's a perfectly symmetrical all the way around circle. Okay, and then for your vertices, that's always going to go with the a value. So you're going to add and subtract a to the variable on top. What I mean by the variable on top, that's not a perfect explanation, is here's a, so if I was doing it for this one, I would be adding and subtracting it to the x values. If it was over here, I would be doing it to the y values. For the co-vertices, you will add and subtract b to the variable on top of that one, of b. So for this one, that would be the y values. So you would add and subtract it to the y values. And then for your foci, c equals the square root of a squared minus b squared. So you basically just subtract these two numbers and do the square root. And this is always along the longer side. Okay, side, and I'm going to put slash axis. It's technically an axis, I just didn't want anybody to freak out when I use that word. And then we're going to move on to hyperbolas. For a hyperbola, x and y can switch places. I'm sorry, these should both equal 1 as well. And I'll give you a second to go ahead and write down these if you want. The main difference between this and this is this minus sign. And what that minus sign does is now it matters which one goes first, which fraction goes first, because this one's technically negative. And on a hyperbola, A is always first. So it's not necessarily which one's bigger or smaller, it's which one goes first. And again, the vertices will still go with A, the co-vertices will still go with B, and this same rule applies down here as well. I'm not going to rewrite that whole thing again, but I am going to draw a line and say that this is the one that gets the curve. This one just helps you create the box. Here's what I mean by that. If I had one like this, I have my center, and then the distance between these 2 points would be A. The distance between these 2 points would be B, because A is underneath X, B is underneath Y. And we make a box out of that. Since X went first, that's the direction the two curves are going to go through. And I'm actually going to go ahead and draw my diagonals like this that go through the box. The whole point in drawing the box is so that you can draw the diagonals that go through it. All right. So let's go ahead and finish up hyperbolas here really quick. The reason why this one is going side to side is because X was first. If Y was first, it would be more like this. I'm not going to draw the whole thing. It would be up and down. That's what I mean by the vertices get the curve. So this one gets the actual lines that go through it. Okay, let's talk about parabolas for a quick second. Here are the equations for a parabola. Y equals and X equals 1/4 P. Sorry, 1 second. Gotta fix my computer real quick. There we go. And the notes I have for you about this one is, so the center is still HK, and then the focus is P away from the center. The directrix is a line that is negative P away from the center. Like this. So let's say it was an X equals 1. That means from your center, you're going to move in the X direction. So let's say the focus was over here. Then I would take that distance, count it out, and go the same distance on the other side and put the line there. The directrix is the one that is a actual line. And then you do need 2 more points to draw the rest of your parabola. That's where you're going to take the distance from here to here. So I'm going to call that 2 for right now. I would go 2 up and 2 down. So whatever this distance right here is, that needs to match this distance right here and this distance right here. And then it draws a parabola. That's kind of a review of this whole unit. There are only going to be 3 of them on this activity though. The 3 that I kind of see as the most important, and that is these first 3. Circles, ellipses, and hyperbolas. Okay. One last thing about hyperbolas is for the foci. It's the square root of a squared plus b squared. So when you're doing the one on an ellipse, you subtract, and when you're doing the one on a hyperbola, you add.